Kia ora Year 12 and any Year 13s who are watching. This is an A-level question on differential equations, but it's also one that's quite good for some Level 3 NCEA practice. And the question goes like this. We've got a curve such that its gradient at a general point with coordinates blah blah is proportional to this. And we're told that the curve goes through these two coordinates, or these 2 points. We have to set up and solve a DE, and we have to find the equation of the curve. So it's very obvious what we need to do. So let's start by forming the equation. And if you're not confident with this, there's a really nice exercise somewhere in delta on this. But this means that dy by dx is proportional to y squared over x. So it equals k times y squared over x. So what we have to do next to solve it is we're going to separate the variables, and then we're going to use these 2 points to find the constants of integration. So separating the variables gives me this. I've got 1 over y squared dy is equal to k over x dx. And I'll integrate both sides. I'm going to rewrite this one as y to the negative 2 dy, but I'm going to get on with integrating this now. So it's going to be k log x plus c. And on the left hand side we get negative y to the negative 1. So let's see what we've got. Well, we've got negative 1 over y is equal to k times the log of x plus c. I'm going to rearrange this now. I'll start by 1 over y is equal to negative k log x. But when I am dealing with this plus c, timesing that by negative 1, we can still write it as plus c. Now, if you're not confident with that, you need to go back to some easier DE questions and think about what the arbitrary constant really means. Okay, so next let's take the reciprocal of both sides, and we'll get y is equal to 1 over c minus k log of x. And now it's time to start substituting in some points. We've got 2 unknowns, we've got c and k, and we've got these 2 points, 1, 1, and e and 2. Let's start off with this one. 1 is equal to 1 over c minus k log 1, which of course is 0, so we get 1 is equal to 1 over c, giving me c is equal to 1. So that's the first part done. Now we're going to chuck that back in and go from there. So we have y is equal to 1 over 1 minus k log of x. And we'll substitute in now the point e and 2. So 2 is equal to 1 over 1 minus k times the log of e. So 2 is equal to 1 over 1 minus k. So you can just look at that and think, well, what number does this have to be? To give 1 over what will give me 2, and k is equal to half, or you can do it properly and get 2 into 1 minus k equals 1. What have I got now? 1 minus k is equal to a half. There we go. It's pretty obvious to me that k is equal to a half. I think it's fine to skip straight from here to here. So we're basically done. We just have to do a bit of cleaning up. We've got y is equal to 1 over 1 minus a half log x. And now we've got y is equal to 1 over 2 minus log x all over 2. So finishing it off, we've got y is equal to 2 over 2 minus the log of x. Now let's have a look at this. We know that that's only defined for x being positive, but I'm going to leave my absolute value signs in there. I'm just thinking about whether that's right. Let's see. Yep, I think I am. There's no restriction saying that x has to be positive. So, and there's nothing that's told me I can drop those absolute value signs. So I'm happy with my answer being that. This is one place where NCEA is a bit stricter than the A-level stuff with keeping those absolute value signs. So that's what I'm getting for my final answer. And that's worth 8 marks. So I think that's pretty easy for a differential equations question in an A-level paper. Let me know what you think, and especially if you're in class with me this year, email me and tell me if you've had a go at it and it's gone okay.